Breathe in the air. Don't be afraid to care.
Welcome.
What happened to your boards?
I am Michael Morgan, if you didn't know.
I'm Larry Quimby.
Annie Larson. Alexander Alschuler.
This is, I've kind of lost count, our 17th or 18th year in a row of doing this, okay? And just a couple brief little words about Michael Faraday and Faraday Lectures. Faraday was the head of the Royal Institution in London, and you have sat in the actual room at an actual Faraday Christmas lecture. Who delivered it? You remember?
No, it's such a long time ago.
Okay. Now, these...
I could look it up. I can remember what year it was. I could find out, but no, I can't remember.
These were given every year at Christmas time, starting in about 1850. And they were lecture demonstrations for a juvenile audience, so that you could bring your kids in. And Faraday was a little eccentric to begin with. And his ideas were out there. But kids do not necessarily have the same hang-ups that adults do. So they very quickly bought into his ideas, most of which it turned out were correct. Now Faraday would do this at Christmas time, okay, make a big deal. He'd go for a week. The most famous of them was the chemical history of a candle. 10 hours about candles, okay? And it was cool. I mean, it actually kept you entertained. So we need to do just a little bit about candles, okay, today, in honor of him, okay? But in honor of the lectures, I mean, it got to a point, the Prince of Wales was attending these lectures because he wanted to learn about electricity, okay, and just thought it was really, really cool, okay? Now we do it just, a yearly event, a nice little get-together. The board's kind of become a tradition. We always like to point out we've lost a few real icons of nerddom in the last year. And that's who we have honored up here. Try to figure some of it out as we go throughout the day. Okay? Now, in wanting to be different every year, our approach this year is a lecture demonstration in 6 acts. And the first act today is called Air Matters. Our theme is air. Now, this is flame, is it not? What do you need to have fire?
Oxygen.
Oxygen? No.
Fuel.
Fuel. Now, you said carbon, but that fuel can be a lot of different things. And what else do you need? We'll use the word ignition, but spark is a form of ignition. So I got somebody in here. Was this Rebecca who lit all these candles? Can't even remember. Gus? Okay. I let Gus play with fire. Candles, got some of these going. Now, in here, I have something that is definitely not air. I've got dry ice. And we're going to talk a lot about that today. Okay? So I'm just going to take some dry ice. I know you put some nice gloves there for me, but who cares? As long as you do it quickly.
And it's your hands.
And it's my hands. I spend enough time in the kitchen, my hands are like dragon skin. Okay, now, what's going to happen here is the dry ice is going to sublime. And in the process of subliming, it is going to push the air out because the carbon dioxide is denser than air, which is basically an 80-20 mix of, oh, you, nice knowing ya.
Don't let him have any matches.
Nitrogen and oxygen, not hydrogen and oxygen. So, we're going to let that CO2 fill up from the bottom and push all the air out and see what happens. Okay? Kind of let that go running. Alexander?
So, we breathe air every day, but
what is air comprised of? We know that air is comprised of matter. I mean, Michael just said that it is about 80% nitrogen, 20% oxygen. But when it comes to, looking at it, we can't really see it, can we? We don't really feel its effects on us because we're used to air being around us all the time. What? 500 milliliters good?
Yeah,
Okay.
doesn't really matter as long as, take a look up there. Can you read it?
What's the volume on that? About 500 milliliters. What's the volume on it now? About 600. What's the volume now? We're at about 500. What did I do? I started off with funnel, inverted. Covered one end of it.
What's in the funnel?
Air. I submerged it into the water. What happened to the level of the water at that point? It rose. Well, why did it rise?
Because the air is trapped in the
Yeah, the air is trapped in the funnel and is then displacing the water. Then what happens when I take my finger off the end of the funnel? Yeah, it fills with water because now all that air has a place to go. The air shoots right out of the top of the funnel. So air is in fact made of matter because it does occupy a volume, does have a mass.
All right, look back over here. We've only got one candle left, don't we? The CO2 is coming up and it's snuffing out the candles, huh? Now, I'm a chemistry teacher, mostly some physics. He's a physics teacher, mostly some chemistry. We have a biology teacher down here.
How do you get
Okay.
in?
Yeah. He doesn't even work here anymore.
Retirement is fun.
At one point in your career, I'm sure you did something that's absolutely going to shock these young children. You dissected critters in your room, and ones that were still alive.
Yeah, cause of death, autopsy.
Yeah. I'm guessing you did live frogs. Oh, you never did live frog? Okay.
Just worms.
One of the very common ones of the 1950s and 60s was mice. And you don't mess with vertebrates anymore. Okay, that's a big no-no. But we send kids across the street where they do. Now, when you did frogs, and I did a live frog in high school, and basically you grabbed the frog, you took a pair of scissors, and you cut the top of its head off. And that severed the cerebral cortex. Instant, gone, supposedly no pain. Okay, can we test that out on you, Ian? Now, guillotine. They don't do that anymore, okay? Because with mice in research labs, they tend to fight back when you try to do that, okay? They do this. They have a tank like this. They put the mouse in the tank, they drop in some dry ice chips, and they go to lunch. And when they come back, Mickey, no more. Okay? The Russians did it to a dog named Laika. Okay? Who knows Laika? Laika was the first living creature sent into space. The US was going to send up a monkey named Ham, a chimp. Okay? But the ASPCA complained about it, so they sent up Alan Shepard instead. Mr. Quimby.
Yes. All right. So we got here. I don't have very hard training with squeeze here. See, that is nice and flowing here. Nice and bottle, all filled with water. And but if I tap on it, pick up squiddy. Okay. Now I want you to go down to the bottom and touch the bottom. Okay. Good, squiddy. Go down, touch the bottom. There you go. Now back up. Stay right there. Okay, just hold still. Yes. Now go back down and touch the bottom again. See how you do that? All right. Okay, very good. And you come up and now, you know how that works? What? You know, come on. Yeah. So what's squeezing the bottle got to do with it? Oh. Yeah, well, there's a little bubble inside a squid. Do you know what the difference is between magic and science? The science we explain it. Yeah, so it's still there's a little bubble inside of the squid here. And when I squeeze, I increase the pressure. What happens to the volume of the bubble? It shrinks, and more water goes in the squid. So now the density is increased. It's more dense than water. And when I relax the pressure, the bubble expands, pushes water out. Now squid is less dense than water and bubbles. And then if you're clever, halfway down, you just get it just right and neutral density. Which is about the way I swim. All the swimming tests is like a 1 foot below the surface is fine.
Yours is better than mine. My swimming is like this.
Yeah.
That's not mine. I stay up at the top.
Now, air, as you have seen in the demonstration you've seen already, air has matter to it. And the particles of air are moving around, and what makes them a gas is that they are moving around very rapidly, and they don't put together very much. So the molecules are bouncing around and bouncing off of each other, and when molecules collide with one another and bounce off one another, they create something. What do we call it? When pressure of the molecules pushing against one another, we call it air pressure, right? Creates air pressure. Well, there's air inside of this bottle. And I'm going to try something with this air pressure. Because if I keep the volume the same as this rigid outside of this bottle will do, if I keep the volume the same but reduce the amount of space and the pressure that the molecules are taking up in here, there's going to be more pressure outside than there is inside. That can have very dramatic effects. Even though we don't think about air pushing on us, air is pushing on us a great deal. So, you watch this. Some people would say that the lack of air inside of there pulled the egg in. That's really a little bit of a false thing because air doesn't pull, it pushes. And it's this outside there that was already pushing on the top of that egg, but was having the inside air pushing back on it and let it just sit there. As you all saw, that egg was bigger than the mouth of this. But when we reduce the pressure inside of here, this air that's out here, shut that egg right in.
Now, the incorrect
There's
term
your egg in a bottle.
would be to say that it was sucked in, right? Science never sucks. Suck is a 4-letter word. It was pushed, but push isn't a 4-letter word. All right, it is time for a Penn and Teller moment. Okay. Now, Penn and Teller are famous for being these amazing magicians who break every rule in magic because they turn it into science. They stop halfway through the show and say, we're going to do that again. And they take the tarp down and they show you exactly how it happens, yeah, how the trick works, okay? So this is a trick some of you will be familiar with from your time with Richard Erdman at UCLA. This is a balloon and a flask, except in the bottom of the flask there is a hole. And what the classic demonstration is you get in front of, some little ones and you say, I'm going to blow up that balloon. You go, okay. And with some sleight of hand work, you put the rubber stopper in the bottom, okay? Take it, goes back, okay? Put this back in, okay? Now, blow up. And it doesn't work, right? It works that balloon is matter. And it takes up space. What is matter? Anything that has mass and takes up space. Okay, do you have mass? Do you take up space? You matter. I mean, you are matter. Now, Caroline,
Yes.
I need a lovely assistant if you
Oh,
would join me.
I can do
She
that.
knows the trick, so I can pick on her.
I can be your kind of one.
She knows what's coming next. So, I'm going to pour this in here.
Yes.
Make a little mess doing it. That's kind of the cool part. Now, the water itself does have some mass, doesn't it?
Yes.
And I think we could say about 1,000 times more than the air that's in there. The density of most gases is right in the neighborhood, that should be good,
Where's the
of,
phone when you need it?
yeah, 1 gram per liter. But the density of water is right around 1 gram per milliliter. Actually, we got a funnel right here, huh?
Yeah.
Let's pour some more. Now, it's a good amount of water in there. Now, do you have faith in physics?
Absolutely.
Or do you want physics in the face? Now, look at that.
Yeah, thank you very much.
Now, I'm going to pull the cap out, aren't I?
Yes, of course he is.
Now, is it going to fly in her face?
Yes. Maybe.
Maybe.
Mayhaps.
No.
No? You don't think I should get her wet? Okay, well you can just watch as I pull it out.
All right.
Now, that's pretty obvious, isn't it?
Yeah.
When the cork comes out, what's going to happen? Air's going to push back in. Now, here's the trick to it that the magician will do for you. Thank you. Fill the balloon till it's overflowing and touching the glass. When I pull the cap out, since the balloon has something in it that's 1,000 times denser, it's going to keep pushing against the wall of the flask, isn't it? And the water's not going to come out until you tap it at the bottom and allow that to vent a little bit and to go through. Okay? All right. A little bit for that. Okay. Now, one that is a little well known to the chemistry students, but it fits this theme of air so nicely. This is water. Some people get that joke and some people don't. I don't think Darren's going to get that joke. Little cold stuff here. Okay. Nice, 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 and cold. Okay. Now, gloves. Get some gloves down there. Now, these.
So you put the gloves on for the dry ice.
Bigger gloves than that? Okay. Now, what I've got here, which might be recognizable to some of my students, is something very depressing. It's an empty can of soap. Okay?
Almost in.
And we put some water in. Okay? And some of you near the front can probably notice there's some steam coming out of here, isn't there? We're boiling the water. That steam has pushed all of the air out of the can. So the only thing in the can now is water vapor and a little bit of liquid water at the bottom. I don't want it to be completely out. So I'm going to try. These gloves are kind of hard to work with. Get this off and then go like that. Now, a lot of water just came out of there, huh? that can, we say collapse, right? But really, we have to back. It was pushed in, wasn't it? There was a lot of water vapor in there, but as soon as that water vapor got cold, what happened to its volume? Yeah, by a factor of about 1,000, huh? Heck, not even more than that, really. It just went down to nothingness. Now, air should run in to replace that, right? This is like breathe out. In, out, out. Except it couldn't because it was upside down. Now, Natalia, can you come up here for a second? Natalia is Darren's daughter. Darren and I have been friends literally since UC Santa Cruz. We met about 1987, 1986, somewhere right in there. My old friends. Come on over here, kiddo. I want you to look down in the can. It's not going to hurt you, just don't touch it because it's hot. Look down in the can. How much liquid water is in the bottom of that can?
I don't know.
That much? That much? More like that? Not even that much? Very, very little liquid water, right? Thank you. See what she can't see is the water vapor. So let's try this again. Okay? Now be thinking about air trying to get back into the can. No air can get in, but water can. Now, I'm going to hand this over. Show that to Natalia this time. Yeah, that look was precious.
Is
there a lot in there?
Is it a lot?
Yeah.
That's a lot of water now. It got pushed in. Okay, cool. Xander, could you? We've still got a pretty good puddle here. I mean, Quimby's clumsy. Okay. Now, who's familiar with William Tell? William Tell. Carolyn, can you tell us about William Tell?
William Tell supposedly shot an arrow off to prove how good an archer he was. He got his son with an apple on his head and shot the apple with a bow.
So this wasn't like, you know, the president of Pan Am with an apple. Or with an arrow.
William Tell overture?
All right, let's do William Tell. Except I don't quite trust Quimby with an arrow. What is that? An air cannon, or sometimes called an air bazooka. I'm gonna come down here. Mr. Larson, give you this. We'll do our version of William Tell.
It's a good thing it's not.
Happy birthday. I think you're a little far.
It's a good thing that we not using a real bow and arrow because we didn't get a chance to practice this today. And I've never like.
You got my ear.
No, I'm a fan. You're gonna have to.
Eventually.
Did you kill 4 people first?
Okay. Now, need to bring this guy down here. Let's go. Oh, I'm gonna go down the front row actually. Run over a few people as we go. Beep, 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 beep.
Just as well.
Just as well. Okay, now, this is a vacuum pump invented by Robert Boyle, the one and only time in the whole year in chemistry we get to talk about an Irishman. Now, I'm going to put this down here to get it out of the way for a few minutes. And this is a bell jar. bell jars are quite famous in chemistry classes, and I tried to recreate a very old demonstration with one once, and I think I pissed off Mr. Larson because I had a period 3 regular chem, and he had a period 3 regular bio, and you gave a very interesting assignment to the kids. They had to keep something alive for 2 months. Now, the smart kid brought in a cactus. Because within a 2-month period, what do you have to do?
Leave it alone.
Leave it alone. But he had a menagerie in the back of the room of mice and hamsters and birds and plants, and one of those hamsters actually gave birth. I know. Dreamy life. But I had this out, so I walked in, and he's lecturing at the board, and everything's really busy. Like, Mr. Larson, and he's walking. I said, Mr. Larson, what? Can I borrow one of the hamsters? And he's like, sure. I'm like, okay. And I walk back and I open up the cage, at which point he turns around and starts screaming. Because once upon a time, in about the 1940s probably, I mean this would predate anybody here, they would take hamsters and put them in a bell jar.
No.
And they would remove the air.
No.
Okay? Now, we're going to do that to our version of a hamster. Don't worry, because even if it does, you won't hear it.
Having trouble breathing?
Is there gas in the balloon?
Yes.
Is there gas outside the balloon?
Yes.
What's the pressure inside the balloon? Equal to the pressure of the gas that is outside. Barbara, maybe you did learn something at the dinner table.
That was me.
Okay.
It's a
So,
student, not
crank it up. Now, the air can leave the bell jar, but the air cannot leave the balloon. So the air in the balloon is still pushing out, but less is pushing in. Okay? We're creating a vacuum. Okay? Or as my cat refers to it, an evil beast called vacuum. Never seen that video? That's one of the best ones on YouTube. It's called Dear Kitten. Look it up. Okay? All right. Now, stop. We're not going to get any more out of this because the balloon has actually covered the hole in the bottom of the vacuum plate. Okay? And that balloon, it's gotten bigger, hasn't it? Doesn't matter, it's not going to explode. Okay, we've tried. The only way we actually get it to explode, sometimes we tape a little thumbtack to the top of this. Now when it pushes up onto the thumbtack, it will actually explode. Okay? Now, are you ready? You're going to hand your book over there to Edward. This is participation. Interesting, huh? What's the first word that comes to your mind? Warm. This isn't a Boyle's Law demo, because I have no way to control the temperature, do I? This is a combined gas law demo, because it's pressure, volume, and temperature. Okay? Don't worry, we'll get you a balloon later. Okay? You and Cody. Because he'll cry like a girl if we don't get it. Okay? Now, oh, excuse me. Get a little hungry.
Can I have one? Wait,
Ready there, Mr. Larson? Crank it up.
No way.
Is there air in the marshmallow? Yeah. Hence the mallow part of the name?
Marshmallow.
No.
Now, this brings up a good time for us to talk about the Stay Puft Marshmallow Man. One of the icons of geekdom we lost this year was Harold Ramis, Spengler from Ghostbusters. Okay. Yeah. All right, turn it off. Now, Xander, you got better eyes than all of us. You're youngish. Thanks. You graduated like 10 years ago. Yeah. Did that marshmallow get bigger?
Yeah.
That's aging. Don't worry, it gets a lot worse than the marshmallow. Okay. Now,
So once upon a time, I did this for a class one day and said, okay, now go home and figure out how can you learn to figure out the density of air from what you can measure here. Figure out, well, we need to do a difference in mass and a difference in volume. And how do you find the volume of that marshmallow? Before it's rather cylindrical, so maybe a formula, but afterwards it's all, how do you do that? Water displacement doesn't work on things that dissolve in water. So somebody got the idea of bring in sugar and do sugar displacement. So and then the word would spread. So the second day I had this out and had this little bag of couple of little bags of sugar up on my front counter and awaiting things, and this assistant principal had to walk in one and make some announcements.
I remember this day.
And he's talking to him, and I'm just standing there behind him, holding up a bag of little white powdery stuff going on. And the class is just trying hard to keep it together.
All right. Mr. Turco, would you be my assistant, please? All right. I got this in Madonna's lingerie sale. She said it was too small. Now, this is another Penn and Teller moment. We're not exactly going to surprise anyone. I have two spheres here. They're solid. And over here, I have a valve, don't I?
Yes.
It's a standard stopcock valve like on plumbing. Turn it 90 degrees and it shuts off. It's a ball valve in there. On this side, I have an O-ring, a rubber gasket, stopper, okay? It gives, right? Now, I'll put these two together, okay? Mr. Larson, need you down here? You know how to run a pump? Okay. Now, what I will do, give me 1 second to put this up. Didn't quite think about this when you put that thing on, but come on. Okay, pull the vacuum. Now, this is kind of. Whoops.
Oh no, we can't breathe now.
This is not. You have to take that off, I think. Put it back on.
Okay.
We switched the whole thing out for doing the other one, and we forgot about this. Okay, now, I've got to hold this. Yeah, there we go. It was making some noise, and now it's not.
Killed it.
And if it's pretty much.
Killed the hamster.
Okay. Turn that off. Now, Mr. Turco, I want you to be brawn.
Okay.
Grab each side
From here?
from there and pull. Let Larry help you.
One hand, okay, one hand. Put the feet
Do you want me to go get a horse? Now, stop. Stop. Why do I make that joke?
Oh, because that's the original megasphere. I think it was a little bit larger than this, of course. This setup and had two teams of horses, one on each side, pulling it, couldn't pull it apart. But, you know, it doesn't take a team of horses to do it. Here, grab it, pull.
Now,
Good job.
it's time for us to get a little technical, a little esoteric here. Okay. Actually, safe science. Use protection. Goggles are important. Now, that is concentrated 18 molar sulfuric acid, which is a wonderful dehydrating agent. This is a beaker of water. Now what I'm going to do is pull a vacuum over that water. Right now, why isn't that water boiling? You want to say because it's not hot enough. I want to say because the vapor pressure in the water does not equal the applied pressure above the water. Now, let's lower the pressure above the water. Will there be air pushing down on the water? No, it will allow the water to come up. Why a beaker of sulfuric acid? It will absorb water vapor. And it actually does it very, very well. Because I don't want to get to a saturated solution above the water beaker. Okay? That would destroy the whole idea. Okay? Fine. Crank away. In other words, I want to boil at room temperature or boil at reduced pressure. Pushing down, good and hard. Okay. It might take a second. Although you practiced this one yesterday, how long did it take you to get it boiling? Half a minute?
I just use a little less water, and you can actually got it to freeze while boiling one day.
Triple point? You hit the triple point.
Yeah, that was cool. It was bubbling and it froze right over.
Okay. There we go.
There it is.
Yep. Bubbles are appearing at the top. So in other words, I'm making water boil. There we go. Oh yeah. In the back, Kevin, can you see it?
Yeah.
That water's boiling. Now, most of you who've been through my class think I'm insane, right? I'm about to stick my hand in boiling water.
But it's not boiling now.
It's cold, isn't it? Yeah. Now, Caroline, I get to pick on the British a little bit today. Although actually this guy's, I think, a Kiwi. Sir Edmund Hillary. Okay, from New Zealand. Okay. Who was Hillary, people? President what? Darren would know. Sir Edmund Hillary. The first white guy. We got to qualify this. It was like first person to climb out of it. No, it's the first white guy to climb, and he had a whole bunch of Nepalese with him carrying his stuff because they just ran up and down the thing every day. Okay. Now he got to the top. What's the temperature up there? Cold. Cold and cold. And atmospheric pressure is like 1/4 of an atmosphere. Okay, you have to wear oxygen tanks to get up there. This is about the most dangerous thing you can do on the planet besides eating my mom's cooking. Okay? Don't make that face, you know that's true. You've had dinner at her house. You have the pleasure, or have had the pleasure, of actually seeing his diary.
I have.
It's in a museum in London.
It's in the Science Museum in London, and they open it up to different pages, and it's usually open on a page where he describes his going up to Everest, and his biggest complaint is on this page, and it wasn't the cold or the stuff they had to carry or the whatever. His biggest complaint about the whole expedition was that he could not get a decent cup of tea. That the tea was awful, and he could not get a decent cup of tea when he was at the last camp before they pushed for the summit.
Because at that altitude, water boils at about 70 degrees Celsius. And it wasn't hot enough to actually extract the tea from the tea leaves. So all that stuff you're complaining about, first world problems, people. First world problems. Okay. All right. Now, Mr. Larson.
I have it set up here. ammonia gas in here. And this is some water, and there's a little bit of an indicator in here as well. I've got some water in this pipette that's right here. Now, some kinds of gases, ammonia being common among them, love water, and they are extremely soluble in water. And so if I put water inside of here, the ammonia that's in there is going to go into solution and form a solution inside of here. Now, if it forms a solution, what's going to happen to the ammonia gas? It's gone into solution, it's no longer there, is it? So what's happened to the pressure? Well, let's see what happens to the pressure.
And remember, science never sucks. What happened to that water at the bottom? It was pushed up.
Pushed up. So when we took the pressure out of here by taking the ammonia and putting it into solution, that little bit of squirt water that we in there, you can see that there's very little gas left inside of here to reduce any air pressure. So all the air that's going in through here, through the opening that's here, is pushing on this water sufficient to push it all the way up that tube and cause it to spray out up in the air. And the indicator that I put in here, when it goes in there, ammonia is a base. And those of you who remember about phenolphthalein, remember that in an acid it's colorless, and in a base it turns pink, doesn't it?
All right. Our next one requires some audience participation. So if Barbara Quimby could join us, okay, Megan help, and Caroline. All right. We need to practice safe science. Okay. Put these on. Now, I have a very technical piece of laboratory equipment here. It's called a straw. Now we've doubled them in length, made it nice and long, protected for your safety. Okay. Hold it like that, and like that. Now normally you slurp up with these things and you drink with them, right? Not today. Today you're actually going to send something the other way. You're going to blow through them. Okay? And we are going to
I've got a tissue. I've got peanuts in there. Oh, there's some in there. Look.
We are going to collect carbon dioxide samples from them. Okay? Now hold the flask with your other hand. We keep the labels pointed backwards so that the audience can see. Keep your hands up at the top. We once had a chemistry teacher here who used to do lecture demonstrations and write numbers on the board like this. So, can the audience at home see the flasks? Please insert your straws into the flasks and start blowing bubbles. Now, for those of you in the home audience, you need to understand that what this is actually a bad breath test. If you get a color change that is clear, your breath is absolutely kissing sweet. However, if your solution turns cloudy, there is a good chance that you had lunch at Phil's barbecue.
Nice
You can stop.
clear here.
Nice and clear for Megan. Kissing sweet.
Nice and clear there.
Sure.
Barbara, what'd you have for me?
Now, Megan, I can't remember. Was it red or blue?
It was red.
Oh, okay.
Red, pink.
That's an acid-base indicator that's like phenolphthalein, but it's called phenol red. It was slightly basic. A couple of drops. What'd you put in? Some ammonia. A couple drops of ammonia. And then the CO2 from her breath. And she's an athlete. Okay? So her lungs are pretty efficient. The CO2 from her breath reacted with the water. Let's make this an AP Chem equation writing question. CO2 is bubbled through H2O and you get H2CO3, carbonic acid. You had an indicator, thymolphthalein, thymol blue. Thymol blue. Okay. Barbara, yours did not contain an acid-base indicator. It contained a suspension of calcium hydroxide. It's called lime water. And the CO2 from her breath reacted with the CaOH sub 2 and formed calcium carbonate. That's the chalk. That's the limestone. Okay? You just precipitated. And your father's in the room. Thank you very much. We can just sit these over in a few minutes. You just hand your goggles back to me. All right. Thank you. Thank you. Thank you. Okay. You? Who's that? Oh, okay. Sorry. Ah, me. Okay. We're going to revisit something. All of my students have seen this, some of them quite recently. It was the hydrogen bonding demo, right? But we're going to put a twist in it. We've got a bottle, a milk bottle. You're probably not used to having milk brought to your door in one of these. Although when Bravo opened, there was still a milkman who worked in this neighborhood. Yeah, for about the first 2 years. Now, when this came to your door, the milk was on the bottom. What came up to the top? The cream. Jack Bruce, bass player for Cream. One of the finest bass players to ever walk the earth. Passed away this year. Now, I have some mesh up here. I'm going to pour a whole bunch of water through it. Making a mess is half the fun. Notice the water's going through the fishnet, isn't it? Passing straight through. All right, where's my tub? That had blue right there.
More of a mess, huh?
Now, I'm going to turn this upside down.
Whoa.
I got it. The fishnet and the water molecules have an adhesive attraction. Hydrogen bonding in the water prevents the water from going through. Now I can tap this, break that attraction, the water comes through, right? We've seen that demo before. Now, Quimby's good. I'm going to have him do the same demo without the mesh.
No net.
No net.
But, let's see if it works here. Think hard. Hard over here. Ah, okay, so far so good. And now, oh, look at that! Throw it out. Gee, why not? Okay. Well, if you leave the card there, it'll stay on a little bit. Why? Because air pressure holding it up and water coming. But, okay, enough of that. Try again.
Mr. Larson. Now, we lost a real icon of geek culture this year, Robin Williams. Now, if you do not know, one of Robin's best friends was a man named Oliver Sacks, okay, who wrote the book Uncle Tungsten, and he's a really famous neurologist. And for Williams, it went in other directions. He was a huge D&D player. Okay? Big fan of video games. Anybody actually know the name of his daughter?
Zelda Williams.
Zelda. That's, yeah.
Yes.
But for your generation, well, maybe not yours, but for your generation, your first exposure probably came to him as the genie from Aladdin. Okay. That movie represented an interesting job for the editors because they didn't give him a script. They just let him go. And every now and then they'd shut him down and say, hold on, this is a kid's film. This is Disney. The mouse doesn't have any genitals. Oh, Aladdin, come on. You got a shield. Use your shield on that. Is that like that? Good. Yeah.
As you all know from the story of Aladdin, you have to rub the magic lamp to get the genie to appear. So we'll get our lamp rubbed here. And if it needs to be taken out or the genie can't get out of the bottle, so the cord from here.
It's a neurotoxin.
Did you make your 3 wishes?
I'm supposed to hear you.
You did see Jeannie, didn't you? Jeannie goes back in the bottle pretty fast with this larger crowd because she gets a little shy. Or whichever Jeannie is, gets a little shy about things. This is really kind of hot. I don't know how Jeannie stands it in there. What I actually have here is a little bit of potassium iodide that's inside of a bottle, or inside of actually a tea bag. Here. And when I took the cork out, the tea bag dropped down into the bottle where I had a little bit of this. This is hydrogen peroxide. Now, hydrogen peroxide in this bottle, you'll notice it's kind of in the bottle. That's because the hydrogen peroxide tends to decompose a little bit. And what's the formula for hydrogen peroxide? H2O2. What does it like to break down to? Water. Water. Water and oxygen. Water and oxygen. So when this is sitting here in the bottle, it sometimes decomposes a little bit, and that oxygen needs some place to go. So to keep the bottle from breaking open, it has these accordions on here. And in fact, when we took this bottle off the shelf, it was stretched out about this long.
Now what happened?
This is not a hydrogen peroxide that you would buy at the store. That's 3%. This is 30%. This is the kind of hydrogen peroxide if you wanted your hair bleached. You went to the you go in and they might put some hydrogen peroxide to some color out of your hair before they put the dye in. Only that would probably be somewhere between 12 and 20%. This kind, but if we put this on your hair, by the time you reach the door, you probably wouldn't have any hair left.
I think it's more like 6% actually. 12 to 20 is sounding pretty harsh.
It decomposed. The potassium iodide in here decomposed our hydrogen peroxide much faster. And in the process, had a very exothermic reaction that released a lot of the gases. And changed things from one form of space, H2O2 molecules, into H2O and gas, the oxygen.
Now there's a nasty rumor going around that I'm a fan of NASA. And on all of the Apollo missions, and even Gemini, all of the thrusting and maneuvering rockets were powered by hydrogen peroxide. All they did was they had a chamber that had a platinum strip in that chamber. You shoot in the peroxide, it decomposed, it built up the gas, and you could release it. And that gas pressure was how you did your thrusters for your maneuvering when you're in space. Okay, so this is the very, very subtle way I say we lost Glenn Larson this year, the creator of Battlestar Galactica. Okay, yeah. So we're bringing air to a close, and we want to talk a little bit about some clouds and things like that. So we're going to start right here with one that you're pretty familiar with. If I can get a few of you to come over here and help me. This is the basic same setup as the bad breath test. Okay? Same indicators. Make them a little basic. But what I'm going to do, on one of them, I'm going to get a little piece of dry ice water, right?
I like to go to the bottom. I'm not used to seeing ice at the bottom of a glass.
This is what chemistry is supposed to look like. Okay. Now, look at this. Color changes, huh? Okay? It's becoming acidified, isn't it?
Yep.
Now, if we add in a couple more pieces and really let it go over, yours is doing good. Yeah, actually it's working really well.
But more is that.
We're American.
I think I got a little far over, didn't I? Please rush it.
I mean, I do like the look of the, like the one with the bubbles around it. Yeah.
Okay. What's this stuff? No, we're being serious. What is this white stuff? What do you call it? Smoke? It's not smoke. This is not burning. Okay. No, that's a very general term. That white stuff is condensed water vapor. The carbon dioxide bubbles, as they come up, are bringing water with them and causing this cloud. When you look in the sky and you see a cloud, like, ooh, look, water vapor. No, a cloud is not water vapor. You can't see water vapor. A cloud is liquid water, and it's very dispersed. It's not that dense, so it doesn't fall until it becomes dense, and then it does fall. We call it rain. Okay? That's what that is. Okay. Are you next? Now, we're American. If we're going to do this, let's do it right.
Call that a cloud. Get you a cloud.
I think the line is going, did you call that a cloud? Now that's a cloud.
Anytime somebody puts on those gloves, you better watch out.
You better not.
All this is hot water.
Now that's a cloud.
That's a cloud. That's fall.
Reminds me of Bonnaroo. Okay. Okay. So, let's get a little technical on you. We do the same thing. Same desk. Okay. Xander, why don't you take them away so you'll actually look at me?
Because it's all about you.
You know, they in teacher school, and they talk about decorating the room and making the room amazing and that. My first 20 years, my room was boring because I wanted to be the most interesting thing in the room. I didn't want kids staring at my displays rather than at me. Okay, so nah, I'm good. Remember Mr. Quimby was telling you that the dry ice was sinking to the bottom? Can I talk? The bottom of the water? Well, look at the stirring rod. Is this water? No. This is glycerin or glycerol. Okay. It is. It tastes sweet. You're right. Okay. They put it in cough syrup to make cough syrup thick. But you'll notice something. There's no water in there, is there? Am I getting bubbles? Yeah. In fact, they're very sizable, aren't they? But I'm not getting a cloud because as this is coming up, the CO2 is coming out, but there's no water to carry out with it. Okay. Now. That was not. It's not nail polish. It's nail polish remover. That's acetone. Okay. Now, the acetone itself does not have that strong intermolecular force of hydrogen bonding, does it?
No.
It's evaporating quickly, isn't it? Now, feel the paper towel. Describe the feel. Feel the paper towel. It's cold because it's evaporating very readily. Who remembers the hydrogen bonding lab about a week ago? Now, I'm done with cleanup, aren't I? Because it is gone in the air. Okay? Looking over here, getting lots of big bubbles, lots of little bubbles, and with this very different density, the little bubbles are staying behind, aren't they? Okay? And the big bubbles being pushed up very nicely. Okay? You and me now?
Yeah.
Okay, so we're American. Go big or go home. A what?
Oh, yeah, we already used that.
Yeah, 7 view. Why don't you go back over there? Stand up, walk back over there. You'll be back in a minute. You too, Jasmine. If you don't like it. This used to be unique. Now you see it on Top Chef every week. Liquid nitrogen. Notice that the little bit of water that's in the air around it is condensing, right? And forming a bit of a small cloud. Forget the small cloud. Let's go for a big cloud. 3, 2, 1. Help me! Oh, you have Help me!
It's boiling.
We didn't use as much water this time as last time we used it.
Where's Mr. Baldwin?
Yeah, it's like when it explodes, you can like
Okay, that is the end of Act 1, which is our longest act. We now go to Act 2, which I must very humbly call an homage to Mr. Wizard. Now, you are young, they aren't. Bob, did you watch Mr. Wizard?
Yes.
You did?
Yes.
Okay. Mr. Wizard was on TV all the time. Okay? He did an afternoon science show. And many of his demonstrations went in one of two directions. One, stuff I would never even touch in my life. It was so darn dangerous. Carbon tetrachloride. He'd blow bubbles in carbon tetrachloride. Yeah. Or stuff from around the house. And really cool things that you could do with things that you found at home. Mr. Larson, you watch that.
You guys come back.
Keep up with time. You need to know what time it is. Your cell phone died. Your watch. Who has a watch in your time? Well, what ship's that? I can make my clock run. Can you all see that? And you can see it blinking. It's actually producing an electric current, isn't it? And it's running the clock. Fine. What do we call it when electrons go from one place to another? Anybody know? Electrical current. And if electrons are moving from one substance to another, what kind of an electrical, or what kind of a chemical reaction is that?
Oh, electrochemical.
An electrochemical reaction. So here we have an electrochemical reaction taking place because ion pairs here, or electrodes, are made of different materials, and therefore the electrons move very quickly from one to another, creating the electrical current running the clock. So next time somebody tells you you have to have a battery to run your clock, tell them, no, you've seen them run with potatoes.
It's kind of a MacGyver moment, you know.
Remember back in the day when we actually had coins that were made out of different metals, you know, like copper and silver.
Kevin Tatt, Cody Lim,
Yeah.
Zach Marcos, the winners of Los Angeles' first
Oh yeah.
Chem Bowl.
Where's Wade?
Okay,
Where's Wade?
it was a college competition. They ran short of teams, gave us a call, said, "Do you want to bring some kids?" I'm like, "Yeah, sure. You know, we'll round it out." They didn't quite realize what they were getting. Okay, we beat UCLA 210 to 12. Okay, Joe Yee from Cal Lutheran, we beat Cal Lutheran 198 to 10. They were texting her while this was going on, and I believe a few phrases used by your students were impolite. Describing our kids. It's like a bunch of high schoolers beating all these college kids.
Yeah, I told them to stick it up there.
The lab portion, which you guys also won, was making batteries out of coins. Yep, ready? This is classic Mr. Wizard. Then again, I've also seen my wife use one of these torches to make a creme brulee.
You trying to put out that flame or something?
Yeah. I could just turn the nozzle, I guess, and turn it off, but this is a lot more fun.
This is a lesson in fireworks. All right.
Oh, I was just starting to have fun.
Flame tests, a wonderful technique for unknown analysis, identifying cations, but also salts are the way we actually impart color into fireworks. You don't really want to stand beneath them when they're going off because there's a lot of strontium and copper falling out of the sky, and it could be a little nasty.
They're still kind of like on fire.
Well, they're still on fire, but that's not what bothers me. What bothers me is that we're dropping something like strontium, and if you're going to ingest it, it has the same chemical properties as calcium. And you don't want the strontium, which is more reactive, replacing the calcium that's in your body. Okay, that could make for a very bad day for your bones, couldn't it? Your heart. And yeah, the heart too. Yeah. Okay. All right. So, this is very much in the genre of Mr. Wizard. Also, take some things from the house. You can do this at home tonight. I will walk you through how to do it. Unique. Yeah, see, but I know her dad, he'll do it. See, you gotta understand, when I was in elementary school, okay, my dad was not the perfect role model, which is really cool when you're a kid. Not so much when you're an adult. But, you know, there was some kids who showed us how to take a 9-volt battery, put some little jumper wires on it, some nails, stick it in water, and you can get the water to bubble. Well, I sit at the dinner table, talked about that, and my mom went. Because 15 minutes later, Dad and I were in the garage with a 12-volt battery, jumper cables, and a bunch of mason jars. And they weren't little bubbles. And then my dad's there with the cigarette lighter going. But that comes later. Okay, so we need some water. Now, how much? Yeah, some. Y'all think chemistry's all these exact numbers, and that's not the way we discovered these things. Okay? We just started with some of the stuff. Now, man, you got the stuff.
I've only got some of it though.
This is a universal indicator. You don't have that at home. But do you have any red cabbage? Okay? Take the red cabbage, grind it in a blender with some water, and run it through a strainer. You've got the same stuff. Okay? A little magnet there. Yeah, okay. When all else fails, plug it in.
Did you charge your meter on and off?
Okay. Get that stir bar going. A little bit of indicator. Okay. I don't know if that's enough or not. We're just going to live with it. Okay. Trip to the drugstore tonight, Mr. Turco. Milk of magnesia. Go and buy the plain wrapped version, the generic. They did not have it at Vaughn's last night. I had to buy the brand name stuff, which was like twice as much. And any of you that know more didn't know one thing. He's cheap.
They have it at the 99-cent store.
99-cent store, there we go. Milk of magnesia is a suspension. Oh, we're not allowed to talk about suspension in school anymore. Yeah. We now do progressive discipline, restorative justice. This is a suspension of magnesium hydroxide, which has some nice buffering ability. So I'm going to put that in there. Okay. And since it is a suspension of something that is not terribly soluble, I can't see through it. Can you? No. Now, it's a universal indicator, and all of you who know about your acid-base indicators, it's on the blue-green side, so what do you know? It's basic. Magnesium hydroxide. Okay. Vinegar. Acidic. Oh. Eat a little bit too much. The stomach produces a little too much. Acid. Okay. And it's becoming acidic, isn't it? The indicator is changing color. Except magnesium hydroxide as a suspension has a buffering ability. Okay? So, if you're just patient enough and talk to the audience long enough, what happens? It goes back to blue. Okay? Now, hit me again. Yummy. That's the fries after the burger. Okay? So, I think it's going to go back again. You know why I think it's going to go back again? I still can't see through it. And if I still can't see through it, that means I still have some magnesium hydroxide left over. Okay? You still prescribe this stuff? He's a doctor, by the way. Is it still used? Okay. Very good.
Turducken.
big soda that time.
I've never had a 4-liter Coke, but I'm willing to try.
I don't think Maria would like that.
She drinks more of it than I do now. Yeah. It's going clear, isn't it? Is it going to go back to blue again? No. So what do you need? You need milk of magnesia, a red cabbage, some vinegar, and a blender. But set the blender at its lowest speed or do it old school. Stir it yourself. It doesn't have to be a magnetic stir. Okay? This is just classic Don Herbert, Mr. Wizard. Stuff that you could do at home.
The origins of this go back even farther, but whatever. It's kind of simple. Let me turn things around so you can see it. I have a double pan balance. And
That's old school.
yeah, literally old school. I mean, yeah, the idea of a balance goes back before recorded history. People figured out if you just got something to hang it, you could compare this weight to that weight. Oh, I got this side. Yeah.
That happened in the castle courtyard.
Yeah, and called before that. You know, the market's place. You know, put gold on one side and then how much I should get over to about 100 grams, and 100 gram mass should have a mass of 100 grams. Which, oh, congratulations. The one thing I like about this is try a string on the bottom here and the weight comes from the bottom. Which you might think, well, so what? That's cool, but green colored water so you can see the water. If I do this, watch what happens. You see it still says 100 grams, right? It still balances. But if I put it in the water, oh, it doesn't balance anymore. Why not? Did it suddenly get lighter? No, it's still the same, but it displaced some water and you got the points before, as I heard. So this goes back to the Greeks figuring this out.
Eureka!
Yeah. And now, if I were clever and could see through an X-ray vision, I'd move this back over and I'd find out how many grams it really does appear to weigh, and it's probably lost 10 or more grams. And if you look at how much did this go up, it went up about, it started at 70 and went up to like 82. I'll bet this one lost 12 grams because 1 milliliter of water is, yeah, okay, you get it. And I always thought, you know, I read about this, but it was so much more interesting the first time I tried it, saw it actually happen. Like, oh my goodness, that works. But you see it in real life is different. So, that's that. Thank the Greeks to figure that. You know, for a long time they didn't know that things floated because they were boat shaped. You know, and then it actually took some work to figure out, no, it's not the shape of the boat that makes it float, it's really nice.
Okay, and that's the end of our homage to this religion. So now, please fasten your seatbelts because we are joining the flying circus of physics. The Flying Circus of Physics is a book by Gerald Walker, Cleveland State in Ohio. He is now the lead author on Halliday and Resnick. And any of you who have been through physics, if you've watched an episode of Big Bang, in every episode of Big Bang, there will be one scene where you see a copy of Halliday and Resnick in the background. It's the green and yellow 3rd edition. They make sure it's in every episode. Okay, yeah. So, we're going to steal the names of some chapters from Walker's book. This one is called Heat Fantasies and Other Cheap Thrills of the Night. So, what we're going to do is take 2 blocks, 2 perfectly identical blocks, right? Same size, same thickness, etc., etc. We're going to sit them down. Okay? Natalia, are you ready? Can you come on, stand over here? Stand out here at the end. Put a pair of goggles on her finger, just for this one. because you know this stuff
You know,
will
it
fly.
might explode.
Practice safe science. Okay, I am going to take 2 ice cubes. Please check those and tell me that they are ice cubes. Feel them. They're ice cubes. And I'm going to sit them down on the block. And I'm going to sit them down on the block. Now,
That's when he switched them out for the glass one.
now, look at the 2 ice cubes. Do you see a difference? Can you describe it to the home audience?
This one is melting much faster than this one, because this one is like almost already, it's turned all to water, and this one's still formed in that.
That's cool. Now, I'm going to make a little joke for those of you that get this. Did it turn into water? It was water. It turned into a liquid state. Okay, sorry, I got to be picky about these things. All right, thank you. Give this goggles back to Ken. Okay, now, Caroline, if I am not mistaken, you teach physics also. Okay, in fact, we've even considered hiring you. Which one's cold? And that's the one where the ice cubes melted, isn't it? Even though it's cold. Now, rub them. Are they the same material?
Well, no.
This is aluminum.
That's much heavier.
This
is
styrofoam. Has nothing to do with mass. Aluminum is an amazing conductor of heat, isn't it? And styrofoam is not. In fact, I'm of a generation where Dad used to have a styrofoam cooler that you took to the beach to keep all your drinks cold before those nice, you know, plastic technical ones. All right, heat tank. Now, we are going to have segregation in our schools once again. You see the dividing line? Okay. On this side, I'm going to put some hot water, and on the other side, I'm going to put some cold water. Now, yeah, there should be a beaker of food coloring there somewhere. Okay. There we go. Yellow's good. This is a little warm. Green's good. Okay, put the green in. You know it's hot because you see the rate at which it is dispersing. Okay? And now it is time to desegregate. What do you know about the hot water? It is not as dense as the cold water. It's going to the top. The cold water is going to the bottom. Okay? Now, you could also do this with 2 different liquids. One that's polar and one that is non-polar. In other words, go home tonight and do it with cooking oil and water.
And for those of you who are in biology or oceanography, what do you call those layers? Thermocline.
Thermocline. Mr. Quimby, the first law. It's down here.
You left it all messy anyway. Okay.
So, we change our theme. We are done with heat fantasies and other cheap thrills tonight. And now the walrus speaks of classical mechanics.
Okay. I didn't know the walrus was here. Cuckoo, cuckoo. So we put physical down first because it's more fundamental than chemistry.
No, I will agree with him. You must realize I got a degree in chemical physics.
So that's for this. Okay, so real fast here, got a little wooden hoop here for doing embroidering, but I don't do embroidering. Just in case you were wondering.
Barbara, did he get that from you?
I think he stole it from me.
I'm sorry, for those of you who haven't figured it out yet, Barbara is Quimby's daughter.
Oh,
They look alike.
you don't wear hair.
It's the hair, right?
Has Robert started to lose his hair?
I'm not good. Don't think so. No.
Not yet? Okay.
All right. Now, you've probably seen the classic demo where you put stuff on the table, and you pull the tablecloth out, and it stays there. Okay. So you probably know what's going to happen when this is a variation. I grab the ring. What's going to happen? And if I just do this, the coin just goes right in, right? Like that. Why? He had to ruin it, didn't he? Why? I know word. Do it again. Okay. This is a tricky part. Get into the balance first.
That's the tricky part.
Slippery. New coins. Small slippery. Okay, now. Sorry,
It worked the first time, don't spoil it.
No, I want, no, there's something else. Why did it work the first time? Why did it do that way? Okay, now, you gonna put some money on.
I'll put some money on this.
Yeah. Is it going to go in or not? The second time. Do you want it to go in? Do you want it not?
Go in. I want it to go
Okay,
in.
in that case, if you lose, it's not going to go in. Why? I'm in control. Okay, yeah. How come it went in the first time and didn't go in the second? Just stop. I'm not hearing the sizzling. You know why I'm using insulated gloves, don't you? Yeah. Okay. Sorry. And this side. Now I'm going to have to do this again twice. This is the first time, but I've got to check. Insulated handle, metal thing here. Touch the outside, put near there, and we got a cute little part. Yeah, that wasn't good enough. So now we do again. Okay, so the lights can go back on. And just kill it, make sure it's not going to drop you on the Okay, charge it up again. Let's see if I can get a good charge. You hear the sizzling first? Yeah, okay, so now we'll go through this again. Gloves are a little bit awkward, as you might guess. Hard rubber wand sort of thing.
And normally he does a demonstration that where he rubs it with a cat fur
No.
to show charge, but the problem is Buddy wasn't willing to give up his fur for the day.
Okay, and then it's dissectable, so here, would you hold this for me, please? There you go. That's good. All right, now, would you kindly hold this one? Oh, they're good. Now, would you please touch those two together? Yeah, just go ahead, touch those two together.
Do it!
Put this in, and then and we'll see if I got a good charge on it, because it's already touched them together. So where's the energy being stored?
You got Carolyn this time.
It's in the plastic. Yeah, the energy is stored in the insulator in the capacitor, not in the metal, not so much in the metal plates. And so it's still charged up. And I could touch the plastic because it's an insulator and it doesn't lose the charge. Alright,
So the electrician is evil. Now is the ring of magic.
I don't know that one. Oh, that one. Oh, okay. Okay, so I need a volunteer again. So we need the ladder here because
Gabby, are you an athlete? Used to be.
Used to be. So you're not in training anymore. Okay. So what I'd like you to do is here. I guess it's got to be this way so the audience can see. So see this? Climb up to the top. Drop it in the top of the tube, run down and catch it at the bottom. And get this fire extinguisher out of the way. We won't need that until later, will we?
Right.
I don't think we need it for this. So, got the idea? You climb up, drop it in, and catch it at the bottom. Alright, I catch it. No? Alright. Pick it up. Let me show you how to do it, okay?
You're an old man. You think you can beat her?
Really? You doubt me? Okay, put it in here, drop it, and then you climb down the ladder, and you come down here, and catch it. You just gotta be fast. All right, thank you very much.
That was slow motion.
How do we do it? This one's not magnetic. It just drops like crazy. This one's a magnet, a very strong magnet. So why would that make a difference? This is copper.
A magnet should not be attracted to copper.
And it's not.
D10.
So how come this falls so slow back? No, that's static electricity, that's stationary. It's falling. No, because James Clerk Maxwell knew by changing magnetic field, as this magnetic field goes, it induces a changing electric field. And you get
One of these.
You throwing your physics gang signs?
Yeah. You know that? Right hand rule.
The right hand rules.
Right hand rule. Okay, X, Y, Z. So yeah, you got a changing magnetic field. The moving magnetic field causes the charges, the force on the charges in the copper to move. They end up going in a circle and they create an electric field and creates a magnetic field, and that repels the magnet and holds it up. Faster the magnet moves, the stronger the current, the stronger the repelling magnetic field. That slows the magnet down. Slowly and drifting down. That's cool. Bending line. Okay. Moving right along in my little physics corner here. Now, got the laser. We got a laser here. At a container full of water. I put a little bit of coffee creamer in there to make it a little cloudy. Actually, I put a little too much in. And let's see if it's still lined up. Hold on, grab the lights back on. Just be clear. I mean, see if it's still lined up. Yeah, still lined up. Okay, so now fill the lights, and you see the beam laser light in the. And if you look at Mr. Larson, black coat, it's all the way over there. Okay, now what I'm going to do.
Careful where you're aiming that thing, Larson.
hole right, well, actually, there's also paint over the hole. But there's a hole in the side of this canister. So when I open this up, air pressure will allow this stuff to come out. First, then pull the tape off. And we get a little more coming out, and then now you notice.
Water's carrying light.
Yeah. I guess from the actual you can actually see the light coming out.
It's shown pretty good today.
And it's not hitting my
So, there you go. Going down.
Did you have too many beers?
No, I didn't. Here is the next one.
Now, there was a young gentleman in my dormitory named Jeff. And some of you in my classes have heard a few stories about Jeff and a can of Coca-Cola. Jeff was a bit of a prankster. And it turned out...
Oh, look.
Hey, the water's holding the light down there, too.
Liquid photons.
It turned out that Jeff, one day, went through and put an acid-base indicator in the punch bowl. And it was red in base. My doctor friend here, urine is basic, isn't it? Yes. And people were in the bathroom peeing red. Now, that gave them a little bit of a scare. That's probably not a good thing. Now, it got worse. It was an indicator that turned red in base. Caroline Morgan. By the way, we aren't actually related, we just have the same last name, but the kids at AP Readiness have taken to calling her the other Mrs. Morgan. What indicator might that be?
Red in the base?
Yeah.
Pink in the base?
Phenolphthalein, the main ingredient of X-Lax. And about 2 hours after they were peeing, you couldn't get into a bathroom anywhere in the dorm. They were in there for hours. Okay, now,
All right.
Professor Ausschuler.
So, how many of you guys have ever tried adjusting the color on your TV? Like, you know, you're playing around with colors, doesn't really look good, and you go into the settings, and there's really 3 settings in there. There's a red setting, a blue setting, and a green setting, right? So, you've got 3 glow sticks up here. Red one, blue one, and a green one. Are these opened? No, they're not opened. Okay. So what I'm going to do is I'm going to open these up, and I'm going to get them started. And what do we expect to see? So, green light.
You call that a light stick?
Dark Morgan.
Okay, so there's the green one. There's the blue one. And we've got the red one here.
Red, green, and blue. RGB.
What do I think is going to happen when I spin it? I think they're going to go flying.
You were right.
I told you. I've been going to practice, so it didn't happen.
So, what happens there? What is the how do you get white light? You combine red, blue, and green. If any of you guys have ever seen any of those really, well, for us that'd be really old, those really old projector TVs, Okay, we grew up with CRTs, but some people had projector TVs in which you saw 3 different light bulbs: a red, a blue, and a green. And when you looked at the TV screen, it looked like that. Exactly. And when you looked at the TV screen, you saw a regular old TV. But if you looked at the little mirror that was there, you saw an image in blue, an image in red, or an image in green. But when they all combined together, we get white light.
Yeah, just very quickly. Oops.
You've got power off of the clock box.
Oh, okay. Put it up here, because like I said, keep it short.
All right. Gotcha.
All right. Somebody gonna kill the lights?
10.
All right. Yeah, this one. So red, green, blue, right? Oh look, maybe everything looks normal. What if I unscrew this and this, and we just do the red light? Things look very different, don't they? Yeah. And look at the shadows. Oh gee, black and red, no problem. You got red and green. Oh, now I got 2 shadows up there. My hand. Yeah, so one finger up there, and I got a red shadow and a green shadow. That's because when the red light's blocked, the green light still gets there. And if I do all 3, then I get, it's hard to see. Oh, we need more white. There's your lab coat. Turn around. There you go. Now you got the cyan, the magenta, and the yellow. The complementary colors. Okay, thank you very much. That's good. But that's different because printing is using pigments which are subtraction, and we add more colors. I don't know if you've noticed, red and green make yellow. They get brighter. It's like that's weird. I can make you see yellow when there's no yellow light there.
Final theme is burning down the house. remember that from your second day of chemistry. Okay? Always be ready for the unexpected. Now, that is an interesting version of this demonstration. This is the more ghetto version. Okay?
I'm not from the ghetto.
See, it turns out it might be hard for you to do this at home anymore, because these are not actually from turkey basters. These are from battery acid fillers. And you can't get a battery acid filler anymore because everybody has sealed batteries. Now, our spark is coming from the lighter of a Coleman lantern. Do you recognize that? You can. That's a lantern lighter. And here we have some ping pong balls. It's like that scene in Blazing's House. How come I always get a busted one? All right, so bartender. That's plenty. Warm it like a fine cognac. This is methanol. In the dorms, we tried it with tequila and it works, but we refused to do it with tequila because it's a waste of tequila.
Okay. Now, don't get your hopes up, because that's the way it usually does for me. Oh no, I'm at 45 degrees. It's the tax on But see, he always gives me the one that doesn't work. Always, every year. See, he keeps the good one. How many knows I don't care? Try this. Yeah, I don't need to. All right.
It's not working.
Yeah.
It's not working.
Yeah.
We will experiment and see if it's the ball.
It's the ball.
Apparently not.
That was a good one.
You give me that ball.
I wasn't seeing any spark.
Let's try that again, Mark.
I wasn't seeing any spark.
I don't see well without the goggles. With? Nah, it's this one. Okay. This is cool.
Yeah.
Okay, and I like this.
Yeah.
It's a good demonstration
For you.
for me. Yeah. But you got to understand something.
Yeah. This guy's clear.
Give me a second. Put that up here. I learned that demo in the dorms of Wisconsin, believe it or not. And it's a good demo, okay? But it,
Small scale.
yeah, I'm from America. That's micro scale. This is micro scale. Just get some left side. Now, this is a band demo. And I also like why the cage bird sings. They don't want us to do this anymore. Mr. Larson, will you go over the light switch, please? C.
But right there.
We came in and we discovered those one morning. And my first thought was, great, Cylons. Some of you get that joke. I'm impressed. Okay? I might have used too much. Good. Very good. We're building up pressure. Alcohol pressure. Volatile. Okay. Mr. Larson, get the back lights. Ready?
Yep.
Good. Warm or hot?
Sorry.
What do you say? That's hot, isn't it? I think that's beyond warm. Okay.
All right. So, we have liquid soap. Over there, that's good.
Yeah.
Yeah,
That's probably
that's
good.
good. Yeah.
Your sword, sir. I like chips. Xander knows my wife very well. She was actually the caterer for your wedding. My wife likes Pringles. No, that's an understatement. That's an understatement. My wife likes chips. Okay. She loves to bake. She loves very high class things. And she loves Pringles. It's just one of those things. Cheese and onion. This can has history. 1991.
Oh, wow.
We've been using the same
Still
one.
haven't blown it up yet?
Still haven't blown it
Well,
up.
we've gone up several times, but it keeps coming back down. Gravity, what a concept.
Can you see me? Can you see me now? We have a pinhole here, right? We have a much larger hole here. That's going to point down. What's inside this can? Please don't say nothing. Air. 20% of that is oxygen, isn't it? Okay? Now.
Oxygen by itself is not enough. You've got to have something.
Xander, could you assist me, please? Sure. Do you know how to work one of these? You got a master's? One more. Yeah. Okay. Now, step far away. Yep. I must tell you, hold on, I must tell you, I need silence for this demo. Because you're going to hear it more than you're going to see it. I'm going to put this down. Don't worry, the hydrogen's trapped. My finger's over the hole. It's lighter than air. We're not losing hydrogen. But I'm going to sit it down. It's going to start coming up through that hole when I bring my finger away, right? Then he's going to light it on fire. And we're going to have a little flame dancing around. Listen to the flame. Because there's not enough oxygen. Don't worry, Donkey, it's not going to hurt yours. Okay?
We'll let you.
Yeah, not yet, Natalia, you're good. You don't have to cover yours yet. I'll tell you when, don't worry. When you can't hear it anymore, there's going to be a problem. You're going to hear this sound. It's going to be my butt closing up. No. You're going to hear this sound. And it means that it's running out of the proper air mix. And all of a sudden there's going to be a 2-to-1 of hydrogen and oxygen. A stoichiometric mix.
Okay. Lights.
Lights.
Ow! That was not.
That didn't work.
That didn't work. May we have one, please? Did it fall over?
No. It blew up as soon as I touched it.
There. Watch the flame and listen. Please be quiet. What a day on that one, huh? Yeah, quiet. I'm still seeing a little flame, actually. It's like a V2.
When you don't hear the voice anymore, that's when
That's when you're staying. Okay. No, not yet. Not yet. Okay. That was the quiet one. No. The next one is not loud. The next one is not loud. Okay. What I have is a sample of alpha particles with 2 extra electrons. Cody, would you like to explain?
It's helium.
It's helium. Okay. All right. So I have a helium balloon. Okay. We got one that wasn't printed?
That's the one you gave me.
Oh, okay. All right. Now, helium is not combustible, is it? Noble gas. Okay. We're going to pop the balloon, and that's it. We're going to just pop the balloon because the flame. It's not going to be that loud. Pop. That's all you can hear. Okay. Got to practice safe science. Okay. Now, I want you to pay careful attention to the candle.
And the flame.
Oh.
You killed it!
All right. There. Right here.
Yeah.
Now, green means go. Yellow is caution. Okay. Lighter than air, right? Helium? Bouncing a little more than the helium? About half as dense? Half as dense as helium. Hydrogen. You are going to get a nice flame. You're going to see a nice fireball. Okay? Think of the Hindenburg. Okay? You want this side? I'm just wondering if we're a little too close. I'll hold it. Okay. All right. Tell me if you want higher. I'm thinking that's about right.
Down before the gods of chemistry and physics.
Oh, nice shot. What's the solvent molecule that's found in you and me? WATR, as bent as it can be.
Oh no.
Water.
Oh no.
It could be linear, and in gases we would all be. WATR, as bent as it can be. Hydrogen. Oxygen. You give it just the right polarity. What's the solvent molecule? We plot its symmetry. WATR, as bent as it can be. Practice safe science. Now, I'm going to make water. I've got two parts hydrogen and 2 parts oxygen. And yeah, 1 part oxygen. Sorry. Now, in the last explosion, there was no oxygen in the balloon, was there? It had to pull it in. Who filmed it? Anybody film it? Play it, yeah. Play it back very slow speed. You'll probably be able to see the fireball go in, not out, because it was pulling oxygen in. The oxygen is now in there. The last reaction had slow kinetics. This one has fast kinetics. Now here's what I need you to do. I need you to take your hands flat and put them over your ears. I need you to open your mouth because we're going to set off something that sounds like a bazooka. I'm not joking. And it's going to hit your chest. And if your mouth's not open, when your lungs go in, where's the air going to go?
Out your ears.
Out your ears. That ain't going to feel good, is it? So keep your mouth open, keep your ears covered.
Don't put your fingers in your ears.
Yes. Yeah. Do not do it like this. Yeah, they might touch. Sorry? Your phones?
No, I remember that's
Oh, you're not going to capture this on video? It's going to go so loud it's likely to turn the camera off.
Oh.
I'm not joking, it's going to sound like a bazooka. Notice we have the doors open. Darren, you got her ears covered?
She's got them.
Yeah, actually step her into the storeroom and watch through the door. Okay, as they say, fire in the hole! Okay, thank you very much for coming. Okay, there are a few obligatory announcements. Cody Lim, Kevin Tatt got their Caltech acceptance letters this week. Michelle Park, I don't see Edward Guzman, got their Stanford acceptance letters. David Ung, A-Team Captain 2010.
Sounds about right.
Okay. Started his PhD at University of Washington. We have Brian Tom from MIT. Jack Holtis from UCLA. Joe Yee, Cal Lutheran. The last I remember, AJ, you were at Santa Monica.
Yes, I will be transferring to UCLA next year.
UCLA? Megan Culp, College of the Canyons, the last I remember.
Yeah.
Okay. Faison, did you graduate?
Yeah, so right now I work at UCLA as a cancer researcher, and I'm at medical school.
Medical school. Thank you very much for coming. If one or two of you want to hang back and help us move some chairs and tables around a little bit, the help would be appreciated, but it's nice seeing all of you. Have a good life. Okay, over here.
Are you like